Hello, good morning, everyone. Welcome back to our English for Mathematics class. Today, we are going to explore a foundational calculus topic called the war of limits. This concept is beautiful because it helps us understand the idea of getting closer to something. Let's begin. Before we seek the formula, let's play a small mind game called the Never Ending Rensselaer. Imagine you are standing exactly 2 meters away from a wall in your room. Every second you walk is exactly half the remaining distance to the wall. In the first second, you move 1 meter. In the next second, you move half a meter, and so on. The question is, will you ever actually get the wall? Think about it deeply and share your unique thought in the text section below. Mathematical that ITT perfectly describe the concept of a limit. A limit means approaching a certain value very closely, but not necessarily reaching it. It describes how a function behaves near a specific point, rather than exactly at that point. We are writing using the notation limits of f of x is x parenthesis c equals l. Okay, now now let's look at this concept from a graphical approach to make it clearer. To find a limit, we must take the function from two sets, the left set and the right set. We call them the left-hand limits and the right-hand limits. There is one golden rule. A limit exists only if both sets upon the exact same value. If they go to different numbers, then the limit does not exist. You might wonder, where do we actually use limits in our daily life? The most common example is instantaneous velocity, which is shown on your motorcycle speedometer. It calculates your speed at that exact millisecond by using limits as the time interval approaches zero. Next, let's learn how to solve limit problems mathematically. There are three primary methods. The first method is direct substitution. The first method is direct substitution, where we'll simply plug the number into the function. If direct substitution gives a 0 over 0 with its n different, we must use the second method, factoring. Okay, let's practice step by step using classic example problem on the slide. We want to find the limit of x squared minus 9 divided by x minus 3 as x approaches 3. First, if we try direct substitution, we get 0 over 0. This is undefined, so we cannot use it. Second, let's factor x squared minus 9 into x minus 3 multiplied by x plus 3. Now, we can cancel out the x minus 3 factor from the top and bottom. We are left with disclosing the limits of x plus 3. Finally, substitute 3 into x, so 3 plus 3 equals 6. And now, it's time for a quick student session to test your skills. Please evaluate the limit of 2x plus 4 is x upon seat 5. Think about whether you can use direct substitution here. I will give you 1 minute starting from now. Okay? While you are writing down the answer, let's review our essential vocabularism. Remember that a pronoun means mendekati and undefined mean tidak terdefinisi. Okay, student, time is up. The answer to the selection is 14 by using simple direct substitution. To wrap up, limits teach us a great life lesson. Even if we cannot perfectly reach a goal, getting infinitely closer is still a massive success. Okay, students, thank you so much for your amazing energy today. See you next week and goodbye.